All right, we're just going to finish up this lecture with a couple details on some other methods of the string. So we move back from list to string. So let's say we had a string such as this. So there is the upper method, and upper method is useful. We've seen this before where you can use it in order to return a string that is all capital letters. Or you can use lower in order to return a string that is all lowercase letters. So what do we do here? We strung together two methods. We started with A, which is equal to this. We converted it into all uppercase, which is this. That is a string that has a class called lower, and so we returned that, or we used that, and then we reconverted it back to lowercase letters. And so again, if you wanted to find this, you would use dir to list all of the methods of the string class, and then upper is right here and lower is right here. You can also, another one we'll cover right now is called find. So if you wanted to find certain parts of a word, so I'm sure you use this in Microsoft Word where you find and search a document, so you can also find and search a string. So the way you would do that is you would do find Watership, for example, and now it lists the index of if there was a match. So when we do that, so 0 we notice, and then 10 right here is the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the 10th index of the list. So then we could, for example, splice it, and lo and behold, we get that word back. If we wanted to just find a space, you can also do that. So the space is the 9th index of the phrase. Let's say we tried to find a word that is not within phrase, then it returns -1. So the way you know that it was unable to find something is it returns the element -1. So that doesn't mean that this was found at the last element. That means that it was never found. It's kind of the way it works. And again, this is case sensitive. So if I did something like this where I searched all the capital letters, it would return it as not found. But if I did this first, now I find it, so I converted phrase to all uppercase, and so now it's able to find Watership that way. So sometimes you might find yourself wanting to string these together because you want to search something in a case-insensitive way, and so that's a way that you can do that. You could also do it something like this, where you first convert it to lowercase, and then you search for the lower case version. But if you did something like this, it wouldn't find it because we've converted all of it to lowercase. Count. You can also count how many times something is found. Let's say we called it so there are 3 lowercase t's. There is 1 uppercase t. If we search how many times tech was found, it would be 4. If we searched, for example, for how often spaces were found, there would be 3 examples of spaces. Pretty straightforward. Join is very interesting. So let's say you had a list. So two, and you wanted to join them all together. So you wanted to do something like this. You might think that you could take this list and convert it to a string and have it and have it create, everything, all these letters joined together. But actually what happens is something much weirder. You have a string that is created, but it almost creates like a literal version of that. So if you wanted to join these together, this is where join is useful. And so what you do is you create the string that is the delimiter of the separator of how you want to combine all of these together. And so then I do something like join. And so now if I do this, I have combined all of the letters in the list together. So again, these are the letters in the list. So I've combined all of these together and I've concatenated them together. If I wanted to have a space in between them, then I create a string that's a space and then I join it together that way. Or I could do something like this, so on and so forth. And so whatever you put within there is what goes in between all of the letters of the list. Let's say you had a set of numbers. Let's say I wanted to try to join those together. You get an error. And so the reason is it doesn't know how to concatenate numbers together. So you need to have strings that are elements of the list in order to use the join method. But now that we have our list comprehensions, we can do something like this. And so what does this list comprehension does? Well, it takes all of the elements of numbers and it converts it to string. And so now we're able to do that successfully. So you start to kind of be able to tie together all of these different approaches in order to do something pretty useful. Split. So if I wanted to, let's say I wanted to have each word in a sentence, or for example, each word of the name of our college, this is where split becomes useful. So I can specify what I want to split on. So if I specify space, what I've done is I've taken this string and I've split it into a list of 4 elements where each element is a string which represents a word. The default use of split is, if you don't provide it an argument, is to split on white space. So that kind of is very similar. But we could have also done something like this. So if we split on of, now we have Georgia Institute and technology. So one thing to notice is that you lose whatever you're splitting it on. So of is no longer part of it. So it's Georgia Institute technology with the hanging spaces, kind of before and after the of. Starts with, ends with. So let's say we have a file name. And I wanted to know, does the file name have the proper extension? So if this was a Python script, it needs to end with a .py. If it was a Microsoft Word file, it would end with something with like a docx. And so, let's say I took input from a user and I need to check to make sure it's the right file type. So you can check that using ends with, and that says to check, are the last letters of this string equal to .py? Yep, awesome. And if I tried a different extension, I get false. So it returned the true Boolean versus the false Boolean. But if I tried something, and if I tried like first script, even though first script is within the file name, I return false because it doesn't end with that. But if I gave it the whole name, then it would be true because, starting from here, it basically ends with that whole thing. Starts with, just the opposite. So, you know, if I did something like that, and true, so it starts with first script, starts with first, but it doesn't start with py, for example. Strip, if I wanted to remove that extension, I can use the strip. And so now I've removed the .py at the end. So it removes it if it is there. If it is not there, so let's say I tried to strip I thought it was a Microsoft Word doc, you'll notice I didn't actually modify this at all. Again, you can use strip without an argument, and what it does is it removes all white space at the end of a string. So here we've removed a single space, but let's say we also had a string that ended with 5 spaces. If we run it, it still removes all of the white space until you get back to the normal string. And then replace. Let's say I had a Python script and I wanted to have a file with the same name, but with the docx extension. So this is very easy. We can just use replace and say replace.py with .x instead. And so we replace the extension that way. You could also replace individual letters. File name dot replace, and so now the p has been replaced with a ... and then the p and the .py has been replaced with a ... And then finally, we've covered this before, but you can always chain methods together. So again, if we did a single t, if we did a lowercase t, there's one uppercase and one lowercase, but if I wanted to know how many total t's there were within it, I could first convert it to uppercase, and now I use count, and now I see that there's 4 t's. And of course, if I did the lowercase here, it would be 0 because I used the upper, so I converted everything to uppercase, and so you just need to make sure you're consistent with what the method was, and then whether or not you're giving it the lowercase or uppercase letter. All right, so this was a lot, but this is where it starts to get fun, so hopefully you enjoy this lecture and you're going to enjoy kind of working on the problems in the class.